Good morning. I'm Engineer Jerry Alibas. I'll be presenting an application in linear optimization, particularly power systems applications. Example, a subsystem has two generators and there are four key lines with limits given by line 1 maximum power is equal to 12 megawatts. Line 2 maximum power is equal to 12 megawatts. Line 3 maximum power is equal to 18 megawatts. And line 4 maximum power is equal to 18 megawatts. The sensitivity relation between the key lines and the generators is given by power line 1 is equal to 2 times the power of generator 1 plus 3 times the power of generator 2, and the power of line 2 is equal to 3 times the power of generator 1 plus 2 times the power of generator 2. Then the power line 3 is equal to 6 times the power of the generator 1 plus the power of generator 2. And the power of the line 4 is equal to the power of generator 1 plus 6 times the power of generator 2. The system benefit functions is F is equal to the power of the generator 1 plus 2 times the power of the generator 2. So we find the maximum benefit value of the system using linear optimization using the Excel solver. So in the right side, we 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 uh, we going to formulate the we're going to maximize the benefit function, which is F is equal to the power of the generator 1 plus 2 times the power of generator 2. So this is the cell, no? And the variables are the power of the generator 1 and the power of generator 2, which is located in the cell M9 and M10 respectively. So the maximum benefit function is equal to M9, so which is the power of the generator 1 time plus 2 times the M10, which is the power of the generator 2. Then we have these constraints. Now we converted the sensitivity relation between the lines and the generators. So we have these constraints. So the equation now is 2 times the power of the generator 1 plus 3 times the power of the generator 2 should be less than or equal to 12 megawatts, which is actually 2 times M9 plus 3 times M10. Then another constraint is 3 times the power of generator 1 plus 2 times the power of the generator 2 is less than equal to 12 megawatts. So which is 3 times M9 plus 2 times M10. Then the third constraint is 6 times the power of the generator 1 plus power of the generator 2 less than or equal to 18 megawatts. This is actually equal to 6 times M9 plus M10. Then lastly, the power of the generator 1, another constraint, plus 6 times the power of generator 2 less than or equal to 18, as shown here in the sensitivity uh, relation between the key lines and the generators, where the different lines maximum power is shown here. So using the Excel solver, so we go to want to add the solver in the Excel. So we go to File, then we choose Options, click Options, then we go to Add-ins, then here below we click we click the Analyst toolbar, then particularly we click here Go. Then we simply check the solver add-in since it is already added in my spreadsheet in my Excel. So I just click OK. Okay, so the objective function is f is equal to pg1 plus 2 times the pg2. So which is this cell. So we're going to click here data. Then as noticed, there's already a additional function which is the solver. So we just click here. Now since I already added the objective function as well as the variable, so let's say we're going to erase these values. We're going to delete. Okay, so set the objective function. So click this one. So actually, this is the objective function to maximize the benefit function. Then we click enter. Then we choose maximize instead of minimum. Then what are the changing variable cells? We click this one. So it is the PG1 and the PG2, or the power of the generators respectively. Okay, then press enter. Then we now add the constraints. So click this add. Then we click the cell, the first constraint, which is this one. Then it should be less than or equal to 12 as seen in this constraint equation. Then we click add. And next cell is this one. It should be less than or equal to 12 again. Click add. Then this time, this cell again, this cell should be less than 18. Click add. Then lastly, this cell should be less than equal to 18. Then we click add. Then, sorry, just click cancel. So we notice that there are already 4 constraints added. Then we choose among the solving method. No, there are 3 options, but we choose the simplex linear programming option. Then it's now to click the solve to find the maximum benefit function. Okay, then keep. So the solver found a solution. All constraints are optimal conditions are satisfied. Then click OK. So finally, we have now the maximum benefit function, which is actually equal to 7.333 or 7 and 1/3 uh, in terms of megawatt, no? Because the units of the power of the generator 1 and generator 2 is in terms of megawatts, where the power of the generator 1 is actually equal to 2 megawatt, and the power of generator 2 is equal to 2.6666 or 2 and 2/3 megawatt. Then as observed here in the constraints, uh, the first constraint is satisfied, if we're going to substitute the values of the maximum and the optimized values of the PG1 and PG2 here in this constraint, so it is actually equal to 12, then followed by this one 11.33, so it satisfies the constraints less than or equal to 12, then followed by this one 14.667, it's less than 18, then lastly the last constraint which is actually equal to 18. So using the Excel solver, we're able to determine the maximum benefit function and the ano, the the variables involved, which is the power of the generator 1 and power of the generator 2 respectively. Thank you.